So let's go over a summary of what we have learned so far. When we're factoring, which we know is the opposite of expanding, we're trying to put things back into their bracket forms instead of expanding them out. Our first method that we can try to use is finding a common factor. So the example that we had was if we have 8x cubed plus 4x squared plus 16x, we can take out the common factor of 4x in here, and we're going to be left with 2x squared plus x plus 4. So in this example, we were able to find a common factor. And that's generally going to be your first approach. Now, let's say you can't find a common factor, and we used an example like this. Now, in this case, we don't have any common factors that we can take out, but we recognize that we have 1 as our leading coefficient. So we're going to be able to find two numbers that are going to multiply to -15 and add to -2. And in this case, when we find those two numbers, we're going to be able to express it as x minus and x plus, and it's as simple as just plugging those two numbers into those brackets, and that is our most factored form. And in this case, we knew it was a plus and a minus because if two numbers are multiplying to give us a negative number, we know one has to be negative and one has to be positive. And in our case, we found that it was x minus 5 and x plus 3, because these multiplied together give us 15, and when added together, minus 5 plus 3 gives us -2. Now, in our last case, if our leading coefficient is not 1, let's say if we have something like this, 6x squared plus 7x plus 1, this was the example that we just went over. Here, our leading coefficient is not 1, so we're going to have to use a slightly different method in which we find two numbers that multiply together to give us 1 times 6, but that can add together to give us 7. And in this case, these two numbers are going to be used to break up this middle term into two terms that then we can use to group together and factor by grouping. So in this case, we found that we could do 6 and 1 as our two numbers, because 6 times 1 is 6, 6 times 1 is 6, and 6 plus 1 is 7. So we broke this 7x down into a 6x plus a 1x, which again, that's just 7x. So this is just a different way of writing down our same expression. And now we broke it up into two groups that we can factor individually. So here we took out a 6x and we were left with an x plus 1. And in this group, we took out just the 1 and we were left with x plus 1. And now we have x plus 1 and x plus 1 that we can factor out and write down whatever we have left, which is 6x plus 1. And that is how we factor by grouping. So again, we're going to first try and find a common factor. If we can't find common factors and we have 1 as our leading coefficient, we can try this simple method here where we find two numbers that are going to multiply to give us this number here and add to give us this number here. And when we find those two numbers, we can simply just put them in our brackets. And if we have an expression where our leading coefficient is not 1, then we're going to factor by grouping, where we're going to find, again, two numbers that multiply to give us our last number multiplied by our leading coefficient and add to give us this middle number here. And we're going to do that so that we can split up this middle number into those two numbers, and then we can factor by grouping. I want to go over one more example where we can actually integrate some of the methods that we've learned. Let's say you had the following expression. 12x squared plus 20x minus 8. When we look at this, we can immediately see that there are common factors in each of these coefficients. Each of these coefficients is divisible by 4. So if we factor out 4, we're going to be left with 3x squared plus 5x minus 2. And that we can see by dividing each of these coefficients by 4. Now, if we look at what we're left with inside the brackets, this expression can actually be factorized even further. So let's focus only on this part here for a second. If we take this part here and use the method of grouping in pairs, we can see that we can factor this even further. So let's use our grouping in pairs method and see what we get from that. If we find two numbers that when multiplied together give us -2 times 3, which is equal to -6, then we need to find those two numbers that when added together are going to give us 5. And because we know that when multiplied together we're going to get a negative number, we know that one of the numbers is going to be positive and one of the numbers is going to be negative. So they're going to have opposite signs. So let's look at our factors of 6 again. We have 1 and 6, and we have 2 and 3. So let's see, if one of these was negative and one of these was positive, which two would, when summed together, give us 5? I think we can immediately recognize that if we have positive 6 and -1, when summed together, that is going to give us 5, because 6 minus 1 is 5. At the same time, when we multiply these together, we're going to get -6, because 6 multiplied by -1 is equal to -6. So we know that our two numbers are going to be +6 and -1. So let's split up this middle term into +6x and -1x. So we're going to have 3x squared plus 6x minus x minus 2. And we have to remember that we originally factored out our 4, so we can't forget that. Now, when we look at this, we can recognize that we can factor out of this group here 3x. So let's factor out 3x there, and we're going to be left with x plus 2, because 3x divided by 3x squared will give us x. 3x divided by 6x will give us, 6x divided by 3x will give us 2. Then if we look at this group here, we can factor out a -1. And if we factor out -1, what is -x divided by -1? That's just going to be x. And -2 divided by -1 is going to be 2. And we cannot forget about the 4 that we originally factored out. Now we see that we have x plus 2 as a common factor here. So we can factor out x plus 2, and we're left with 3x minus 1. and the 4 that we originally factored out. And now this is actually our most factored form. And this is how we would factor this expression right here.